All right, Algebra 2 friends, we're going to deal with some more logarithms and exponential functions. Okay, so we're going to point out just a couple problems as we go. So one thing we're going to do is be able to use these problems if they have a common base. That means can I write 16 and 8 as something to some power and that something in the bottom to be the same. So very commonly think of 16 as 4 squared, but I can't write 8 as 4 squared. So I'm going to have to go the whole way down to 2. So I know 8 is 2 times 2 times 2, so that's 3. 16 is 2 to the fourth. But notice what's going on. This one carries also a 3x on there. Okay, so 16, 2 to the fourth. So then it's still to the 3x. What do I do with a power to a power? Well, then I'm going to multiply those. So I now have 12x equals 3. So we're going to drop those bases, divide by 12. So that means x turns out to be 1/4, 1/4. And so what I can do is I can say 16 to the third, take that to the 1/4, or just take 16 to the 3/4, right? If I get 8, then I know I've done this correctly. So I'm going to give you a way to check that out when we have those common bases. That's using un calculator. Okay. All right. What if we have different bases? Like, I don't care what you do. There's no way to put this thing the same. So there were a couple properties of logs. We had when we add them, we multiply. When we subtract, we divide. And there was another one that said we can take this guy right here and drop it in front of there. So that's what we're going to do. But to do that, I have to introduce the log into the problem. So I'm going to say log, log, log. So now it becomes 3x log of 15 equals log of 285. And now that I have this, I'm going to go ahead and divide by log of 15. Okay, so 3x equals whatever this number is, right? And I'm not even going to write it down. It's just whatever comes out on the calculator. So log 285. Okay, I like to hit enter. Otherwise, you have to close parentheses. Divided by log of 15. Okay, so we're going to get 2.087, da, 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 da. But that's not the answer yet. Divided by 3. Okay, divided by 3. So you get 0.696. Okay. All right, so if they can make them in the same base, right, that's totally a lot easier to change those base than it is to introduce the log, do some of this writing, and then calculate it up. All right, the next thing we can do is I can ask you to go to Desmos and drop these two things in here. So what I have is one equation is simply y equals 4 to the 3x. The other one is y equals 15. And then what I'm looking for is the point in which they cross. Okay, I'm going to find the point in which they cross. Now, keep in mind what we're solving for, right? X equals, X equals. Okay, that's going to be the X value. So X turns out to be 0.651. So we have a way around it, and it doesn't matter if it's the same base or not. We can drop both of these into Desmos or a graphing utility like your calculator. You may just have to change the window to find out where they meet, right? If I have a y equals 15, I need that window to be a lot taller. In Desmos, you're just going to zoom out until you see what's happening here. All right, so this is where the chapter really falls into place. Okay, so wood is sustainable, renewable natural resource when you manage the forest properly. Okay, your lumber company has 1.2 million trees, and you plan to harvest 7% of the trees each year. How long will it take you to harvest half the trees? Okay, so I have 1,200,000. I want to know when there's half of that. Well, half of that would be 600,000. We're going to harvest, right? We're going to take away 7%. We're going to keep 93% of the trees. Wow, that goes way back to the beginning of the chapter, right? We want to know how long until that happens. So here's what we do. We divide it by the 1.2 million. Guess what's going to come out here? 1/2, right? 0.93 to the x. And then the next thing we're going to do is, since the variable's in the exponent, we're going to take a log of both sides. So log of 1/2 equals, I'm going to make it 0.5 equals x log of 0.93 and divide by log 0.93. Okay, so log 0.5, again, either close parentheses or hit equals divided by log 0.93. 0.93. 0.93 divided by log 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 0.93. So that means x turns out to be 9.55, and in this case, it's going to be years. So that means we have to make sure that we're planting those. Otherwise, in about 10 years, you're going to lose half of all your trees if you haven't found a way to, sustain what you're doing. And that means, you won't be in business much longer unless you find a way to take care of that. All right, so exponential equations tied in here. Remember, 7% is going to go back to 0.93, what we have left. The 600,000 is because we want to know how long until we harvest half the trees. Okay, so there's a little bit of reading involved when we get to some of those. All right, now I give you this as a preview question in our last pair deck if you're in my class. Otherwise, you have no idea what I'm talking about. Remember, log no base is a base of 10. So we're going to go ahead and since it's log of x, I can't solve it this way. So we're going to change it out. It's a single log, so we'll do that. So 4x minus 3 equals 10 squared. Why did I write that? That's 100. Let's add the 3. So 4x equals 103 and divide it by 4. Okay, so whatever that comes out to. We don't even really care. Okay, it's going to be some sort of decimal, and we'll be all set. The only thing we really care about for this one is that it's positive. So positive times a positive right here. And this is going to end up being greater than 3, okay, because I can't do log of a negative, so that's really the only thing I'm looking out for here. But this was a linear, so it's not too bad to deal with. Okay, so 103 divided by 4. All right, that's going to come out to 2575 anyway. Okay, so either one of these, we're in good shape. All right, now we worked on log properties for quite a while, because what I might ask you to do, I'm definitely going to ask you to do it, is if I'm adding two logs, what do I do with these? I multiply them, all right? So we're going to put those together. So I have log x squared minus 3x equals 1. There is no base, so what should I use? I should use 10. So that means it's x squared minus 3x equals 10. We're going to subtract that over, and we'd really like to factor this one. Okay, are there factors of 10 that are 3 apart? For sure, 5 and 2, and we want -5 and +2. But we still have to get some answers. So x equals +5 as we solve equals 0, equals 0, equals 0. The other option is -2. All right, so quick check here. I have log of x, so I definitely cannot use a negative. Okay, so that means we're going to keep the positive here. If for some reason this number were less than 3, right? If I had 2 minus 3 would give me log of a negative, so that wouldn't be good either. So we want to check each one, but as soon as one of them doesn't work, we can get rid of that -2 right away. All right, so what else we got? Yeah, we can do all sorts of problems like this. So this is why we spent some time on our log properties, right? I see subtraction, so this becomes log 6 over top of 3x, and it equals -2. Well, 6 over 3 is 2, so I'm going to fix that so this doesn't become any hairier than what it is. So it's 2 over x equals -2. It's log of x, so I have to change it. There's no base, so the base is 10. Okay, so I have 2 over x equals 10 to the -2nd. So how can I rewrite that? Well, I can make that 2 over x equals 1 over 100. But now we can just cross multiply. So I find out that x equals 200 to get that answer. So I'm going to go back to the original and check. 3 times 200 is 600. Can I take log of 600? You betcha. Sure can. Sure can. All right, so if you're working on paper, I left this together so you can kind of write all the stuff out and do whatever you need to do over here. Otherwise, if you're working in OneNote, there's a little more space here. The odds are good for today, as we'll continue to work on this quite a bit. All right, so we really chopped it up into the different things we can do. So keep an eye on what's going on with those, right? So same base, then we get to different bases. I can tell because it's saying round it, so there's no way to write those together. We can make a table or use the table out of Desmos. We're going to find out when they meet, right? So we're going to do y equals, a separate y equals. We can use formulas, and then we can start to change them out to solve them. And so those are the things we worked on together. today.